Hello guys, welcome to Roland High School Math Room, where high school math education is being made easy for your better understanding of high school math concept. Now, today we are studying the topic, the introduction to rational functions. Introductions to rational functions. And when we talk about rational functions, what is the meaning of rational functions? Let's proceed to the formal definition and intuitive ideas about rational functions. Now, a rational function is a ratio of two polynomial functions. There is something that we need to put in mind here. Polynomial functions. What is the meaning of polynomial functions? We have a lesson on polynomial functions on this particular channel. Take your time and go there and study. So we have a rational function is a ratio of two polynomial functions expressed as r of x, that is a rational function in terms of x, is equal to f of x divided by g of x, where g of x is not equal to 0. The moment g of x becomes equal to 0, the whole function becomes error, mass error, that is undefined. Now, like rational numbers being fractions of integers. So when we talk about rational numbers, they are fractions of integers. Rational functions are fractions of polynomials. So what we need to understand about this particular step is such that since rational numbers are fractions of integers, when we move the same understanding to rational functions, then rational functions are also fractions of polynomial functions of this particular nature. Now, for example, we can have r of x equal to 3x plus 1 divided by x squared plus 3. When you look at the top, it's a polynomial, and this is polynomial of degree 1. And you look at the denominator here, it is also polynomial. So when you attribute this expression to the rational function expression here, f of x is the same as 3x plus 1, g of x is the same as x squared plus 3. Now, we also have another example. We have f of x equal to x squared plus 4x plus 1 divided by x minus 1. This is another example of rational function. That is a function in the form of a fraction where the numerator is a polynomial function and the denominator is also a polynomial function. So the numerator here is a polynomial function and the denominator is also a polynomial function. Now, let's move to the next concept, which is about proper rational function and improper rational function. So here we are having proper versus improper rational function. Now, for example, let's look at this particular rational function. So for a rational function of r of x equal to f of x divided by g of x, if the degree of f of x is less than, and this is the less than sign, the degree of g of x, then r of x is said to be a proper rational fraction. I hope you understand that. So here we have a rational function, and remember, anytime you have a fraction, you have proper fraction and improper fraction. Whilst you are in your primary and high school level to junior high schools, we've learned that anytime you have a fraction can be put in a proper fraction and improper fraction. So when you come to rational function, which is also a fraction where the numerator is a polynomial fraction and the denominator is also a polynomial fraction, that particular fraction can also be proper and improper. Now, what make it proper? And as we are saying here, if the degree of f of x is less than the degree of g of x, then that particular rational function becomes a proper rational fraction. Now, let's move to example. For example, we have f of x equal to 3x plus 4 divided by x squared minus 4. There is a polynomial of degree 1, and there is a polynomial of degree 2. So as such, we are having a proper rational function or rational fraction. So this one becomes a proper fraction. Now, if the degree of f of x is greater than or equal to the degree of g of x, then the rational function, which is r of x, is said to be an improper fraction. So anytime the degree of f of x, that is the numerator, becomes greater than or equal to the degree of the denominator, then the whole rational function becomes improper fraction. Now let's proceed to see an example. So we have g of x equal to 3x cubed plus 5x squared plus x plus 1. Here it is a polynomial of degree 3. So the degree of this polynomial is 3 because the highest powers of the variable x is power 3. That is the independent variable. And when you go to the denominator, we have a polynomial of degree 2. Why? Because the highest power of the variable, the independent variable x, is 2. So it means that the degree of the numerator is greater than the degree of the denominator. As such, this particular rational function becomes an improper fraction. Now, an improper fraction can be expressed as the sum of a polynomial and a proper fraction through the process of polynomial division. Now, remember, anytime you have an improper fraction, we can write the improper fraction as a sum of a number and a proper fraction. Now, let's look at the expression that we are talking about here. So, if h of x is a rational function and it is improper, it can be expressed as quotient, which is another polynomial function, plus remainder over divisor. The remainder over divisor will create a fraction, and that fraction will automatically becomes a proper fraction. So that is what we are saying here. So anytime I have an improper fraction, I need to put it in mind that the improper fraction can be expressed as a sum of polynomials, which is the quotient, and a proper fraction through the process of polynomial division. Now, for example, if we have 127 divided by 25, remember 127 divided by 25 is an improper fraction. So if it's an improper fraction, then it can also be written as 5 plus 2 over 25. How did we do that? We used long division method to divide 125 by 25. So the quotient will be 5 and it will be remainder, there will be a remainder of 2 divided by 25. So remember, 2 over 25 is automatically a proper fraction. Now the next thing for us to do is to know how to express improper rational function as a sum of a polynomial and a proper fraction. So now, what we have to remember is that a rational function is improper when the degree of the numerator is greater than or equal to the degree of the denominator, as we've learned earlier. So here, we divide the numerator by the denominator by using long division method to obtain the results of the form, that is a rational function which is improper, which is p of x divided by k of x equal to s of x plus r of x divided by k of x. What do the s of x represent? So we have the s of x representing the quotient, that is the polynomial. And we have this r of x over g of x being the proper rational function. Now let's proceed to see a unique example where we have to express this particular improper rational function of f of x. And what makes this particular rational function improper? It is improper because the degree of the numerator is 3 and the degree of the denominator is 2. So if we want to express this as a sum of polynomial and a proper fraction, that is, bring it to this particular format, then we have to use long division method of long division method of polynomial division. So here, the long division method of polynomial division can be done in this particular expression. We write the dividend here and the divisor at the back. So x cubed divided by x will give us x squared. So you multiply the x squared by x times and also by minus 2. So x squared times x will give us x cubed. X squared times minus 2 give us minus 2x squared. Then plus 0x plus 0. Then we subtract this new result from the old dividend and have a new dividend. So x cubed minus x cubed give us 0. Minus 5x squared minus 2x squared give us minus 3x squared. 4x minus 0x give us 4x, minus 3 minus 0 give us minus 3. Then we also divide minus 3x squared by x and we get minus 3x. So the minus 3x times x will give us minus 3x squared. Minus 3x times minus will give us positive 6x. Then we subtract this result from this new the dividend that we have here, and minus 3x squared minus 3x will give us minus 2x. Then 4x minus 6x will also give us what the expression here. 4x minus 6x will give us minus 2x. So here this side will be 0. Then minus 3 minus 0 will give us minus 3. So we repeat the same process till we realize that the degree of the new dividend becomes less than the divisor. So here we have to continue because the degree here is 1 and the degree here is 1. So it's supposed not to be equal. It has to be less than. So we have to continue the same process. Minus 2x divided by x gives us minus 2. Then minus 2 times x gives us minus 2x. Minus 2 times minus 2 give us positive 4. Then when you subtract this result from the one that we have here, we have an answer to be minus 7. So the degree of this one is 0, which is less than the divisor. So now we can rewrite this particular rational function as the quotient. And what is the quotient? X squared minus 3x minus 2 minus the remainder, that is the remainder out of x, this is minus 7, divided by the divisor, that is x minus 2. So as such, we've been able to express this particular rational function as a sum of a polynomial, which is the quotient, and a proper rational function. So this one is a proper rational function. So let's proceed to work examples. So here the examples are for you to try your hands on them. So what we need to you need to do at this particular try questions is for you to state whether the following rational function is or are proper or improper fraction. And if it is improper, express them as a sum of polynomial and a proper fraction. So we have the number 1, 2, 3, and 4. Please, this is a challenge work for you. Try your hands on them and send your feedback and your results to us on this particular channel. Don't forget to subscribe to continue to receive the rest of this particular lesson, which will help you to understand the concept of rational function in a very, very easy form. Thank you.